So I actually thought this was our last lesson, and then I was going through things this morning. We still have another lesson, and I didn't even realize it's still on inequalities. But sorry to disappoint you guys. On Friday, I was like, "This is it. We're at the end." But no, now we still have one more lesson after this. So my fault. I apologize for that. Didn't mean to get you guys' hopes up. But so we'll go ahead and we'll go through this. This is going to be on the assignment. And then tomorrow is going to be the quiz. And remember that you guys have access to calculators. You can use, I like Decimos for graphing. So let me go ahead. I'm going to pull that up right now so we have it handy. And I just go here and Google it each time. And let me get rid of that. And let's start with our first problem. So the first one says describe the features. So we could sketch this by hand. Because it's super easy, not spend the time putting in the calculator. A lot of times, again, we're used to seeing this over here. It's personal preference, but when we write it like this, x plus 2 is greater than or equal to my y minus 3 squared, then it's always the opposite signs of both the values when you look for that vertex. So sometimes it's easier for you guys to go ahead and do it so you don't have to worry about, do I keep this line the same or do I have to flip it? So when I talk about my vertex for this parabola, it's going to be, this is my h because it's with the x value, the k is always with the y. So it's going to be -2, -3. It's an x greater than, and my y is what's being squared. So that means since the y is being squared, it's going to open left or right. It's opening left or right. Since this is a positive y squared. Oh, yes. I'm still waking up today. It is a -2, +3. -2, +3, take the opposite sign of both of them. So since this is a positive out in front, it means that it's going to open to the right towards the positive numbers. So we know that it's going to open right. It's going to open right. So my graph would look something like this. I'm going to go -1, -2. I'm going to go up 1, 2, 3. There's my vertex, and it's going to open. It's equal to. So remember, if it's equal to, it's a solid line. If it wasn't equal to, then it would be a dashed line. So it says it's greater than or equal to this. So now my question is, where do I shade? Where do I shade? And so I need to figure that out. And so I could pick a test point. I could pick something like this point right here and plug it in. I could pick my 0, 0. Now here's my hesitancy with 0, 0. In this case, it's fine because I drew it to match this. But sometimes you don't know, is your graph going to open up really wide like this and hit that point and include it? Like sometimes when you get really close there, it may not be so black and white into, is that point should be inside the graph or not? So you don't want to pick something that you could question, is it inside or not? If I had a parabola, if I had a graph like this and it opened up like this, I can easily pick 0, 0 because you know for sure it's not going to be part of that graph. So just something to think about as you're picking points. This point down here, it can't be part of my graph, so I know that. So again, it's a preference. So if I pick this point, I want to know, is it going to be part of the graph or not? So if I use the point -2, 0, and I plug it into my equation, I could either use this equation or this equation, they're equivalent. I plug it in and it is true, then that's part of the shaded region. If it's not true, then it's not shaded. So you're shading your solutions. So let's do a check. So I'm going to go ahead, I'm going to use my x plus 2, my y minus 2. So here's my x, my y. So I'm going to do -2 plus 2 is greater than or equal to 0 minus 3 squared. So this is going to be 0. Is that greater than or equal to -3 squared? Is 9. So is 0 greater than or equal to 9? Not true. So that means this point is not part of the solution. It is not being shaded. So I would not shade this point, which means I'm shading everything that's inside here. Everything that's inside. So I would have either shaded everything outside of the parabola, around the parabola, or inside. So let's go through those questions. It says, check all that apply. The parabola has a vertex. Yes, this is the vertex for all of them, but it says opening to the left. Nope, because we can see it's opening to the right. And so it's obviously not opening up as well. It's only going to be one of those. Then it says quadrant 2 is not shaded at all. Well, what are our quadrants? We kind of haven't used that lately. So remember quadrant 1, quadrant 2, quadrant 3, and quadrant 4, just as a quick little review. So quadrant 2 is not shaded at all. That's not true. See, there's shading right here. This is all part of quadrant 2 right there. So that's not true. Quadrant 3 is not shaded at all. If I look here, this is not shaded at all. So this is going to be the other one that is true. Again, you can plug it into the calculator. I'll plug the one on the back into the calculator just so you guys could see calculators, but I won't do it for each one of them. So I sketched it here. If you wanted to plug in the calculator, you could have plugged in the calculator. Here, I like them when they give us the graphs. We don't even need to worry about plugging in the calculator. So here's what the information is telling us. Here's my H, here's my K, because whatever's with the X is my H, whatever's with the Y is always my K. So I know that the center of these hyperbolas is going to be at 2, 1, 2, 1. So if I go to look at my point 2, 1, 2, 1, the center, well, the center's got to be somewhere on this line here. So that's not going to be it. Again, 2, 1. The center for this one, though, you can see is my vertex is going to be here. It's got to be on that line. So that's not going to be it. Let's go 2, 1. And I can see that this is centers are on that line. So that's a possibility. And again, my 2, 1 right here. So this is going to be a possibility. So I can look according to the center. The other thing I could have looked at was the fact that this is an X first. Since my X is first, then I know it has to be opening the same direction as the X axis. So it has to be left and right. So I could have crossed it off because these ones open the same direction as my Y axis. So I should have known then that those two could have been canceled out. So two different things, you could have crossed those off right away. So we need to figure out, okay, well, which one of these is true? Is it shaded all here or inside the hyperbolas? So pick a point. This one's an easy one to choose. Choose your 0, 0. So if 0, 0 is true, if it's true, if it makes a true statement, then this is going to be the correct one. If 0, 0 makes a false statement, then this is going to be the correct one. It's not shaded. So let's check. We're going to use 0, 0. So I'm going to plug it. I'm going to have 0. So this is my X and my Y value that I'm plugging in for X and Y. So it's 0 minus 2 squared all over 25 minus 0 minus 1 squared all over 9 is less than 1. So this is telling me 2 squared is 4. So 4 25ths minus 1/9, is that less than 1? So I have 4 25ths minus my 1/9, and I have 0.049 is less than 1. Is that true? Yes. There we go. I should point out, I chose 0, 0. For once, when you actually have these values where there's perfect squares like this, using the center, we talked about it with the circle, using the center works out really well. We don't necessarily have it with this one always being the same. You can't use that vertex because it's on the graph. But when we talk about these and their perfect squares, using the center often works really well. So I'll point that out. This is usually my go-to point because for all the problems that it usually works, it's like the easiest to work with. It cancels out things. But if I look here at the center and I use my center for these problems that are perfect squares like that, it works out nice because this would be my X, my Y, and this would be 2 minus 2 squared all over 25. Minus this would be 1 minus my 1 squared all over my 9. So these would zero out. This would be a 0, 0, which means this whole thing would be 0. So 0 is less than 1. And so you can see that as well, that is also true. So this was easier to use as center, but you're still going to get the same answers. My next one. Showing that 9, 1 is a solution of which inequality would justify shading the inside of the curve. Okay, so it's saying that 9, 1 is a solution. So which would that justify? Which would that be true for? So remember, if it's going to be a solution to it, it means it has to be true. This point right here, the center we said is a solution. It was true. So 2, 1, it was true. So that's a solution because it was true. It's part of the shading. So it's asking you, which one of these would this be true for? So you need to plug them in. So here's your X, here's your Y. So this is saying 9 squared minus 1 squared is greater than 84. This gives me 81 minus 1 is greater than 84. So 80 is not greater than 84. So that's not your answer. So all you're doing is plugging these in. So again, 9, 1. So here's my 9 is greater than or equal to 3 times 1 plus 2 squared minus 2. So 9 is greater than or equal to, this is going to give me 3 squared is 9 times 3 is 27 minus 2. I already know that 9 is not going to be greater than 25. I'm going to stop right there. So that's a no. My next one, so I'm going to have 4 times, this is going to be 9 minus 4 squared minus 16 times, this is going to be 1 plus 1 is squared, is that greater than 36? So I'm going to go ahead, 9 minus 4 is 5, 5 squared is going to be 25, and 25, well, we'll do 4, I'll write it out, 4 times 25, minus, this is going to be 1 squared is 2, 1 plus 1 is 2, sorry, 1 plus 1 is 2, 2 squared is 4, so it's going to be 16 times 4, is that greater than 36? So this is going to be 100, 4 times 16 is going to be 64, is that greater than 36? Well, this is 36, is 36 greater than 36? No, not true. Some of you guys go, but wait a second. It'd be different if it had the equal sign there. If it said greater than or equal to, then that would be valid. But it says strictly greater than, and that is not a true statement. So we know it's going to be this one. Let's go ahead and check it out. So 64 is going to be 9 minus 8 squared plus 12 times 1 squared is less than 144. So this is going to give me a 1 squared. So 9 minus 8 is 1. 1 squared is going to be 64. So I have 64 plus 12 is less than 144. 86 is less than 144, which is true. So that means that 9, 1 is a solution for this problem. It's in the shaded region. So that's going to be only true for that last one. If you guys have questions, please let me know. All right, backside. So Miranda graphed this graph here. So when we look at this, we like to have this x by itself so that we actually have the coefficient in front of the squared term. So I'm going to go ahead, I'm going to divide everything by 6. So when I do that, I have 1/6 y plus 1 squared is greater than my x minus 2. You don't actually need the parentheses there. You can have that, or you can leave it like this. It's a personal preference. So this would be my h and my k. So if I wanted my vertex for this, my vertex would be at 2, -1. The y is being squared, the x isn't. So the one that's not being squared, that's the axis it's going to go along. So I know it's going to open left or right. And because this is positive in front of it, in front of my squared term, Since it's positive, it's going to open right. So let's see, what do we have here? It says, which can Miranda use to justify that her graph is correct? So because only, sorry. Because only the y quantity is squared, the curve is a parabola. Yeah, because only the y is squared, we know it's going to be a parabola. It only has one square term. True. The parabola opens right because 6 is in front of the x quantity. So that's where they had it originally. But yes, it's still going to open right because you can see here, we already talked about it's going to open right because it is a positive value. There is a strict inequality, so the boundary is included in the solution set. So the boundary is included. What did we talk about with the boundary, right? Got to remember all this stuff, huh? So we know it's going to open to the right. I have my vertex. It's going to be at 1, 2, -1, somewhere here. So when this opens, so all right, my graph, this says it's strictly going to be greater than, so it's going to be a dashed line. It's going to be a dashed line. This line creates the boundary, so vocabulary. This one says the boundary is included. That is not true. The boundary would be included if we had an equal sign and this was a solid line, then that's when the boundary is included. So boundary is included when you have a greater than or equal to or less than or equal to. So that is not included for this one. This also says, so the shading is outside the parabola because 0, 0 satisfies the inequality. So we want to check our 0, 0. So x, y, we're going to plug it in. So I have 1/6 of 0 plus 1 squared is greater than 1 minus 2. So I have 1 squared is going to be 1. 1 times 1/6 is 1/6. This is going to be a -1 there. I could have plugged it in here or here, doesn't matter. So is 1/6 greater than -1? This is true. This is true. So this point is part of the shaded region. So we would shade everything outside the parabola. So this is the shading is outside the parabola because 0, 0 satisfies the inequality. This is a true statement. The values subtracted from x and y in the equation are the coordinates of the vertex. So the vertex 2, -1. Yes, this is true. So all 4 of those were true and there was only one that was not. And our very last one. So this one says, some steps are shown in converting the following conic inequality from general form to standard form. Complete the conversion and identify the shape, key features, and which ordered pair is part of the solution set. All right, so I can tell from right here, we could determine what type of conic it's going to be. So there is no xy term, which means we can look at just our a and our c value. So remember, if there's an xy, then that's when we use our b squared minus 4ac to figure it out. So this would be my a, this is my c. So I know a is equal to 9, c is equal to 4. So my a times c is greater than 0, which makes it an ellipse. If one of them was negative and it was less than 0, it'd be a hyperbola. If a and c were equal to each other, it's a circle. And if I have an a is 0 or c is 0, in other words, I don't have one of the square terms, then it's going to be a parabola. So we know we're working with an ellipse just from looking at that. The next thing says, like, where's the center? Well, in order to figure out where the center is, we need to have it in standard form. So I'm going to start from right here. So you can see where they factored out our GCF. I'm going to take that spot, this step right here, and I'm going to rewrite it down below. So I'm going to have my 9, and I'm going to have x squared minus 2x plus my blank, plus my 4. This is going to be y squared plus 4y plus my blank is greater than 11 plus my blank plus my blank. Okay, now remember when we do this, I had here I had a coefficient other than 1 when we had these groupings. And again, I had a coefficient here of 4, so I had to factor out those values. That's where these came from. Now remember, this is going to each term. So whatever's here is really 9 times that value. So what I add over here has to be 9 times that value. Same thing here. This really gets distributed to each piece. So what I'm adding here is really going to be 4 times that value. So what I add to one is that I have to add to the other. And I'm going to get this in standard form. So we're just completing the square. So it's just a little bit of a review. So I take half of this middle number. So half of -2 is going to be -1. -1 squared is 1. So my 1 is going to go on my line. I look here. This is a 4. Half of 4 is 2. 2 squared is 4. So on my line here is 4. So when I go to write this as a perfect square, it's going to be 9 times whatever squared goes in for my perfect square, plus this is going to be 4 times y, whatever's being squared goes in here for my perfect square, is greater than, this is going to be 11 plus 9 plus 16, which is going to be 36. Almost in standard form. Remember, this has to be set equal to 1, so we're going to divide everything by 36. And when I divide it by 36, 9 goes into 36 4 times, 4 goes into 36 9 times, and I get my value of 1 here. And I'm left with the equation x minus 1 squared all over 4 plus y plus 2 squared all over 9 is greater than 1. And here's my equation, which is great because now I can easily identify my center. Remember, h goes with the x value, k goes with the y, so my center for this one's going to be at 1, -2. So this is going to be at 1, -2. The next one says which is a solution to the inequality. So which of these is going to be a solution? It's a drop-down menu. So I'm going to go ahead and show you. You can graph this, but for this, like honestly, I would have probably just go to my calculator. And I'm going to show you guys this one again because of the fraction. Sometimes it throws you guys off on how do you put it in. So this is going to be x minus 1. Let me pull up this piece squared, and it's going to be divided by 4. And then I use my arrow key to move to tab it over so I can go ahead and go to the next term. So plus, and then it's going to be in parentheses, I'm going to do y plus 2 squared. And then I'm going to divide that by 9. And then I'm going to use my arrow key so I could get it, my cursor, so it's not still in the denominator, and it's strictly greater than 1. Well, here we go. Okay, so we're going to have these graphs. You're going to have this graph, so it's going to give you some points. So the answer for that problem, let me show you guys this. Oh, wrong thing. So many tabs. Okay, so the answer for this problem, the selecting one, it's going to be 2, 0, and it says, or -2, 0, it says, is a solution inequality. So what I would do when I'm looking at this options that they gave me, I would go look at my graph, and I'm looking here, and I go to -2, 0, which is this, which would be right here. And I can see it's shaded. So that is a solution. They might have given me another option, might have been like 1, -1, and that wouldn't be an option where my arrow is because it's not in the shaded region. So the answer that is going to be correct is -2, 0, which is this point right here where my arrow is, because it's in the shaded region. So they're going to give you a list, and you just need to look, is this point in the shaded region or is it not? But you obviously need the graph to look at it. So you could graph it yourself, or you could just graph it using Desmos. So whatever you prefer. And that's all I have for you guys today. So again, don't forget about Desmos as you go through these. They actually graph the inequalities as well. You do need to understand how to do the concepts of them, because some of them, like these, you have to work them out by hand. You can't use graphing. I mean, I guess you could, but it'd be a lot of time as well to do that. So up to you guys. If you guys have questions, let me know, and good luck on your assignment. I'll see you guys tomorrow. Thank you. You guys have a wonderful day too. Bye.